Hi guys, welcome to my channel. I hope you all are very well. I'm going to cover important topics of system design from this video, and I'm going to upload number of videos related to system design in this series. So let's come to the point. Suppose you have developed a service and it is being used by a number of users, and when you see huge number of users have started using your service day by day, then you realize your server and machine cannot handle these many large number of requests. So it means it may stop responding anytime. So now you need to find a solution to scale your application for the large number of requests. So how will you solve this problem, and what approach you are going to follow to scale your application? So that we are going to talk about in this video. So you can solve this problem by adding the extra hardware, or by upgrading the current system configuration. So what it means? By adding the extra hardware, it means you can add extra servers, and by upgrading the current system configuration, it means you can upgrade the capacity of a system, or we can move to the new bigger machine. So that is move to the bigger machine. So these two things are called the scalability. So by the scalability, we can scale the application to serve the large number of requests. So based on these two definition, we have divided scalability into two parts. One is the vertical scaling, and second is the horizontal scaling. Okay, so what's the vertical scaling? Vertical scaling is the scale in. It means we are upgrading the capacity of a single machine or moving to a new machine with more power, or we are moving to a bigger machine with high power. It means where we'll have a more CPU, more RAM, we'll have a more storage capacity. So it means we are upgrading the capacity of a server. So that is my vertical scaling. An example of vertical scaling is MySQL and AWS RDS. Now the second type is horizontal scaling. It means it's a process if we are adding more server into the pool. So we can add as many as server we need. And Cassandra and MongoDB are the example of horizontal scaling. So these were the type of scalability. Now let's come to the difference between vertical and horizontal scaling based on some points. So first point is the load balancing. So load balancing, it means whenever we have a number of requests, a huge traffic, and we have some servers to serve those traffic, then we need to distribute that traffic, that request, among these servers. So to distribute that traffic, we need something that is called a load balancer. So in the vertical scaling, we don't require load balancing, but in the horizontal scaling, we require load balancing because we have number of servers in that case. But in the vertical scaling, we have only single server, so we don't need load balancing. Now the second point is the failure resilience. So in the vertical scaling, failure resilience is the single point of failure. It means because there is only one server, so it means if that server will go down, then the whole application will go down. But yeah, so in the horizontal scaling, it is resilient to the system failure. It means if one server will go down, then we can redirect that request to another server. So it means we can achieve the availability of the data. But in the vertical scaling, we can't improve the availability. Okay, so in the horizontal is resilient to the system failure. Now the third point is the machine communication. In the vertical, because there is only single server, so the communication will be interprocess. So design interprocess communication, so communication will be fast. But in the horizontal scaling, we have number of servers, so the communication will happen between the machines through the network calls, and that network call will be slow. Okay, now the fourth point is data consistency. in the vertical case, in the vertical scaling, we have data consist. We will have a data consistency because there will be only one server to serve all the requests, so data will be consistent for sure. But in the horizontal scaling, data will be inconsistent because different server are serving different requests. So in that case, we will have data inconsistency. Now the fifth point is limitation. So limitation, it means because in the vertical scaling we upgrade our system by increasing the CPU or RAM, but there is some limit to do that. It means we have hardware limit. In that case, we have finite limit to capacity. But in the horizontal scaling, we can add as many as server we require based on our requirement or our budget. So yeah, in horizontal scaling, scale wells. So these were the differences between vertical and horizontal based on some points that we discussed just now. Now the point is where we can use the vertical scaling and the horizontal scaling. So vertical scaling is very great option if you have very less number of traffic and very less number of requests to serve. Then in that case you can go with the vertical. But in the horizontal scaling, will work when you think your number of users are going to be increased day by day, and there will be lot of requests to serve. Then you can go with the horizontal scaling, and or you can go with the combination of both. So the choosing between the vertical and horizontal, it's all depend on your requirement. So first observe the requirement of your application carefully before making a decision, and if your requirement can meet by just increasing capacity, then go with the vertical, or then otherwise you can go with the horizontal or the combination of both. I hope you got the description of scalability, and this was all about the scalability of system design. And if you have any questions and suggestion, please add in the comment below. And thanks for watching my video.